Welcome to the 922 Inequality Notes. Today we are going to start with reviewing the process we started learning yesterday in how to solve inequalities, and then we will end the lesson with an application problem. Let's get started with our first few inequality problems here. So I like to think of solving inequalities as a three-step problem. So our first order of business is to find our boundary point. So that is going to be that very special number on our number line for which our solution set is either bigger than or greater than. And sometimes that boundary point is included in our answer and sometimes it's not. So that's why we have to be very careful whether we fill in the point or leave it open. To solve for our boundary point, we change the inequality sign here to be an equal sign. And then we solve like normal, like we normally solve equations. And I get a boundary point to be x equal 5. My next step is to put that boundary point on a number line and decide if 5 should have a filled in point or an open point. So because this symbol is a less than symbol and not a less than or equal to, there's no equal sign included there, I want to leave this point open. 5 is not included as part of my solution. I next have to decide whether I want to shade to the left of 5 or to the right of 5. And so how I figure out which side is the solution is I pick any point and I test it. So I would try to be very strategic in the number you pick. Would we pick 489? Probably not, because that would be kind of annoying to plug in for x. I would urge you to pick something simple, like 0. So I'm going to plug that into my inequality and see if it makes it true. Is it part of my solution, or is it false? And therefore, I would shade the other side. Is -7 less than -2? Yes, it is. And so that tells me that 0 is part of my solution. So I shade the side of my number line with 0. My last step is to write this in interval notation. And so I look at my number line and I figure out how can I write the most simple inequality to represent this interval. So it looks like I have all of the numbers, all of my x values are the solution, that are less than my boundary point 5. And because 5 is an open dot, an open point, 5 is not included, there is no or equal to. I want to use the sign less than. Awesome. Let's try letter D, even though it's not alphabetically next, it's kind of visually next. So let's see if you remember what to do for part 1. We solve for my boundary point. So I change my inequality to be an equal. And I solve like normal. If you need a little help, it looks like we have to distribute this -3. You might want to draw that little rectangle. And now I can just solve this equation. You don't have to do it in this order, but I like to take care of my x's first. So I get a boundary point of 3. X equals 3. So my next step would be to put that on a number line. It looks like my sign does have an or equal to. It does have that equal sign included. So I want to make sure that this point is filled in. And then I'm going to test point 0 again, although actually I think the point 1 would also work out kind of nicely, but I'll stick to what I said and kind of pick 0 again. But you don't have to pick 0. So I'm going to plug in 0 for x and see what happens. 2 minus 3 times negative 1. So negative 3 times negative 1 would give me a positive 3. So what I get is 5. 5 is greater than negative 7. That's definitely true. And so I would shade the portion of the number line with 0 because that gave me a true statement. My last step is to create an interval based on this. And so I would say my solution are all the x values less than or equal to, because that 3 is included, 3. Because I shaded to the left, it's less than. Because it's a filled in dot, it is or equal to. So those are our first two. Let's try a couple more here. Letter B. First step is to change it to an equal sign and then solve normally. So I get a boundary point of 2. My next step would be to put that on a number line and figure out if it's filled in or dotted. Because it's an or equal, it's a less than or equal to, I want to include it in my solution, so I'm going to fill it in. And now I have to figure out which side of the number line to shade. So again, I'll pick 0 as my test point, and I'm going to plug it in for m. And so 3 times 0, that would just give me 0. So I get 2 on the left-hand side there, and then 8 times 0 is 0. 0 minus 8 is just a minus 8 there. Is 2 less than negative 8? Is 2 less than or equal to negative 8? Absolutely no, that is not true. That's false. So 0 is not part of my solution set. So that means the other side of my number line is the solution. So you shade the other side. In this case, 0 did not work out. So we don't want to shade that side. Now I want to write this as an interval. So this would be x, all of the numbers that are bigger than or equal to 2. Since we're going to the right, that's greater than, and because my 2 is filled in, that's where that or equal to comes in. Awesome. So let's try letter E, and then I'm going to have you try the last two on your own. So step 1, rewrite with an equal sign. So let's see, over here I would get 9k minus 3, negative 4 plus 1, equals, these are like terms, 2k plus 7k, that's 9k minus 3. What? What happened here? Craziness. We got the same thing on either side. So there is no boundary point, right? We've talked about this type of equation this year in algebra. When you have the same thing on either side, there are infinite many solutions. Any value of k would make this true. Infinite solutions. There's no one k value that makes this true. They all do. So what we can assume about that is then this inequality is always true because it's really the same thing on either side, and because the inequality is less than or equal to, they will always be equal to each other. They'll always be equal to each other, so this thing will always be true. So there are infinitely many solutions. I don't have to go really any farther. I guess we could make a number line. Let's try it just for fun. So if I were to make a number line, I guess I should put some number on here, right? The whole thing would be shaded. And then if I wrote that as an interval, it would be negative infinity to positive infinity. And this is kind of a stretch, right? We haven't really talked about when there's infinitely many solutions, but that is what it would look like. The reason there's no or equal to here or here is because infinity is not a number, so there's no way you can ever be equal to it. All right, at this point, I am going to pause the video, or you should pause the video, and try letters, what are the last two letters? C and F at the end. So try them on your own. Pause the video and try them on your own. And come back to the video, and I can tell you I am going to be looking for your work when I return to school on Monday, but the answer is P is greater than -3, so that would be your end answer. And actually for this one, you should have gotten no solutions. So make sure you've tried those, but there are your answers for those two. Thank you for watching the start of 921 video lesson. 922. We are going to do the application problem next. So close out of this video and find the next video. Thank you.